Now in this question we're asked to calculate the acceleration of the car from B to C. Now remember, the gradient of a velocity time graph is equal to the acceleration. So we're going to use this method to calculate the acceleration of the car from B to C. So we need to work out the gradient of this line here. And this gradient will be equal to the acceleration. Now I've already taught you how to calculate the gradient of any straight line graph in another lesson. So remember, we called the gradient m. And to calculate the gradient m, we needed to do the up distance divided by the along distance. Or some students and schools use the formula rise divided by run. Now remember, to work out the up distance and the along distance, we need to choose two really good points along this line and then draw a triangle between these 2 points. Now you can choose any 2 points that you want, but I think that the easiest points to choose are the points at the beginning and at the end of the line. So I'm going to draw a triangle between these 2 points. So I take my ruler and I draw a triangle between these 2 points. And remember, your triangle must be drawn with horizontal and vertical lines only. Now we need to work out the up distance of the triangle and the along distance of the triangle. And to do this, we're going to have to read off some more values from the graph. Now we already know where this point starts from. It starts from 50 on the y-axis and 4 on the x-axis. So I take my ruler and I draw a vertical line down from point C until I get to the x-axis, and horizontally across from point C until I get to the y-axis. Now a lot of students make a big mistake at this point because they write down that the up distance of the triangle is 85. And hopefully you can see that this is completely wrong, because the triangle didn't start from 0. The triangle started from 50 and it finished at 85, which means that the up distance of the triangle was 35. And then the along distance we work out the same way. So the along distance here finished at 14 and it started at 4. So the along distance of the triangle was 10. Now we can work out the gradient of the line. So the up distance was 35 and the along distance was 10. So the gradient is 35 divided by 10, which is 3.5. Now remember, the gradient of a velocity time graph is equal to the acceleration. So because the gradient is 3.5, that means the acceleration is also 3.5. Finally, we need to put the units of acceleration. And remember, acceleration is measured in meters per second squared. This is now my final answer for the acceleration of the car from B to C. And finally, you'll notice that this section of the graph is steeper than this section of the graph. So when the graph is steeper, it means the acceleration is bigger.